want to talk to you about partial fraction decomposition of a rational function. First of all, what's a rational function? A rational function is a function of the type some polynomial over another polynomial, P over Q. So it so happens that if Q, if the denominator is factorable, we can decompose the rational function and break it apart to smaller, nicer pieces, so we can work with it in a very easier manner. There are 4 distinct cases that we know for partial fraction decomposition. And in this video, I want to talk to you about the case 1, and I'll do more videos for other cases. So case 1, change color, case 1. Decompose P over Q with, or I mean, instead of that, saying Q has only non-repeated linear factors. Okay, let's have an example. Let's go to the next page. Suppose you have the rational function of, let me put here example, x over x to the second minus 5x plus 6. Notice that the denominator is factorable. And in fact, if I factor this, the denominator, I get x minus 2, x minus 3. Notice that this is case 1 because both factors are linear and they are not a copy of each other. X minus 2 is distinct from x minus 3. So this equals sum A over x minus 2 plus sum B over x minus 3. And now our job is to find out A and B. So this part is just, you're gonna have to take my word for it. I'm not gonna sit and prove this to you. So this part, yeah, you're just gonna have to, for now, accept this. And then our next step is to find A and B. How do we do that? Let's multiply both sides of this equation by least common denominator, x minus 2, x minus 3. So multiply both sides by x minus 2, x minus 3. If I do that, what do I get in the left-hand side? I only get x, because x minus 2 times x minus 3 and the denominator cancels out. What do you get on the right-hand side? I get a times x minus 3 plus b times x minus 2. Okay. Let me go ahead and go to the next page and continue. If I distribute a and b, I get x equal a times x minus 3 times a plus b times x minus 2 times b. And notice that this is the same as saying x equal. I have x in here and x in here, so a plus b times x minus 3a minus 2b. All right, so you probably asked that, why was this helpful? It is helpful because this equal sign right here is telling us, or rather demands, that a plus b must equal 1. Why is that? because the coefficient of x on both sides must be the same for the equal sign to hold true. So if this coefficient here is 1, then a plus b must be 1. That's the only way that we have this equation holding true. And how about minus 3a minus 2b? How about that? Well, that must equal 0 because I don't have any numbers dangling on the left-hand side. There's nothing in there beside the x. So now notice that I have two equations, two unknowns. So I can try and I can solve for a and b. Let's call this one equation 1, call this one equation 2. So from 1, I can claim that a equals 1 minus b. And then I can substitute this in here. So minus 3, instead of a, I have 1 minus b, minus 2 times b equals 0. So minus 3 plus 3b minus 2b equals 0. That is just a b, and add 3 to both sides, I get b equals 3. And if b equals 3, now I know a equals 1 minus b, so which is 1 minus 3, so that equals negative 2. So a equals negative 2 and b equals 3. So for the final answer, I can write that x over x squared minus 5x plus 6 equal a, and we found out that a happened to be negative 2 over x minus 2 plus b was 3 over x minus 3. I personally don't like this form very much. I personally like the format of x over the factors, x minus 2, x minus 3. I like this one better, equal 3 over x minus 3. And since this one is negative, then I'm going to write this one then 2 over x minus 2. Okay. So I hope you understand that why I like this one better, you know. So you probably, some of you have seen this and you say, hey, I have seen this method that you use cover and tell without doing algebra. Is that true? Is that a shortcut to this? And the answer is for case 1, only for case 1, for non-repeated linear factors of the denominator, it is true. So what do I mean by that? All right, so let me go to the next page. Here's what do I mean. Pretend that you're on a step of x over x minus 2, x minus 3 equals sum a over x minus 2 plus b over x minus 3. So the shortcut, and I do recommend it, that if you're continuing particularly to differential equations to learn this shortcut, it'll come handy. Here's the shortcut. So what makes this denominator 0 in here? Okay, positive 2 makes this denominator in here. So if I go on the left-hand side and pretend I'm putting my hand on the top of this part, you know, because 2 minus 2 is 0 and I can't have a 0 in the denominator. Let's pretend that doesn't exist. Now, if I plug in the 2 for x, I get 2 over 2 minus 3, that equals 2 over negative 1 equals negative 2. And notice that that was the value of our a. We found that value of a to be negative 2. How about negative, how about value of B? If you want to use this method, which is different people call it differently, cover and tell, it's just, I don't have a name for it. So, but if you want to use this, what would make this denominator 0 under, under B? The denominator that makes, x of, so 3 would make that denominator 0. So just pretend that you're putting your hand in here and you're not looking at this. And then plug in 3 in here. So we get 3 over 3 minus 2. That's 3 over 3 minus 2 is 1 equals 3. And so the value of B is 3. So B equals 3. And this is the exact same value that we found just previously. Now, once again, one last time, I want to emphasize that this method of cover and tell works only with case 1, which you have, non-repeated linear factors. Okay, I'll do more on case 2, 3, 4 on different videos. Thanks.